So union intersection, that's new?
Yeah, I think so.
Okay, cool. So we'll go through and do that. So intersection, if you have intersection, the word that's associated with that is going to be this and. So I want to put that in first. And if you think of an intersection other than math, where do you see intersections? Yep, on streets. So if you have a street coming this way, a street coming that way, you can put in the dashed lines. But the intersection, you agree the intersection should be
The yellow zone you're going to put in.
this part here in the middle, right?
Yeah.
So that red part there is going to be the intersection. Do you agree the intersection is only the part of the street that's in both streets?
Yeah.
So that intersection is in this one here that runs east-west, you could say, and this one here that's north-south on a map. So the intersection is going to be only what's in both. The same thing is going to be true for math. When we start talking about inequalities and having multiple inequalities, like, hey, x is greater than 2 and x is less than or equal to 4, if you see that word and in the middle, and means intersection, so it's really the answer is going to be just what's both in both of those. What's in the x is greater than 2 and what's in the x is less than or equal to 4. Yes? Normal people just go through and put this in as the answer. I just kind of want to show where the answer is coming from, doing those 2 lines above it. So you really could just skip and just do that thing at the bottom if you wanted to. It's up to you. But okay, if we do this x is greater than 2, I'm going to put my 2 over here a little bit closer to the left. Open circle, closed circle. Open circle, because it's saying x is bigger than 2. It doesn't include 2. And if it's greater than, we shade to the right. So that blue thing there is going to be what's the solution be to x is greater than 2. I'm going to put my 4 over to the right of 2 a little bit. Put a 4 there. And now if we have x is less than or equal to 4, we have open or closed? Closed, because that includes the 4 as part of the answer. So you put a dot, a filled in dot on the 4. And now we shade to the left. So my answer then is only going to be what's both the blue and the green. So it's really going to be just kind of this like middle part in there. So I'm going to say, well, at the 2, we have to have open or closed circle at the 2. Open, yep. But so we want everything that's bigger than 2, so it's going to start headed to the right, but we have to stop at the 4. So the filled in circle there. So the intersection of those 2 things is going to just be this kind of, I don't know what you'd call it, blue, green, aqua, whatever color, in that bottom one. Does that make sense?
Yes.
It's only the stuff that's in both
So we don't have to draw
inequalities. So sometimes you won't have to draw arrows. And there was great rejoicing amongst the crowd. Okay. So, but you also lose the chance to make ginormous arrows because you're bitter. Okay. Solving and graphing. So this next one or 2 we're just going to do at one time. So my lower limit is the number -4. So I'm going to put a line for my -4. Open or close circle? Close. Perfect. Nicely done. Because -4 is less than or equal to x, or you could read that backwards and say x is greater than or equal to the -4. So now we're going to, no, I need to totally read my question. I got way too excited. I'm sorry. We need to erase that.
Oh, dear.
Yeah, I did that on purpose just to help you see the, okay, thing was up.
Since I'm ready.
You can leave the thing on your line if you want to, but the -4 is going to be wrong. Okay. What I was anticipating the teacher doing is having like just an x there in the middle. What do we have to do to make it so it's just an x?
-5.
Yep. So do you agree we subtract 5 here? And you do it to each side as well. It's kind of like before we had it like this here, you'd subtract 5 from both of those, and we kind of like cover up this part like it doesn't exist. But now we have 3 different sections, so we have to subtract 5 from every section. That cancels this out, just leaving us the x. But now my lower limit isn't -4, it's -9. So -9 is less than or equal to x, which is less than or equal to 12. Okay, so now I'm where I'm supposed to be. So I have this -9 now as my lower limit. Degree still filled in circle? It's less than or equal to? And then that's going to go, from there we'd be shading to the right, but we stop at the number 12. So put a 12 somewhere over there on the right. Has to be on the right because larger numbers are on the right. Because it's less than, or x is less than or equal to that, we do a closed circle there too. And we shade in between. No arrows. Woohoo! Any questions on that one? Feel free to work ahead if you want to on this
We're
one.
not done.
I'm going to go through and first of all, so we're solving. We have to do order of operations backwards. Everybody's good with that? We're doing it in like all three places, kind of the Y. All right, so then I have a 12.5 is less than or equal to 2x is less than or equal to 25. And now it's 2 times x, so we divide by 2 to get x by itself. So I have a 6.25 is less than or equal to x, which is less than or equal to 12.5. And typically when you see an inequality like this where x is between two numbers, you know you can go through and put those two numbers on. Now sometimes it's going to be open circles. I wish I had made one of these just less than. But both my examples I have the less than or equal to, so they're both filled in circles on those two pegs, those two ticks, and you shade in between. So that gets us to the end of page 1. Any questions on page 1?
How many pages are there?
I think 2.5, something like that. 2? Okay. Not as bad as I thought. All right, union. I don't know how familiar you are with unions. I wasn't really when I was your age. But unions work like this. So like there's this United Auto Workers Union. So General Motors, so my grandpa worked for General Motors. He was part of the union. And they try to get all the workers at the factory or at the plant or the whatever being in the union. And then, so instead of like the company talking to each person individually, what do you think we should pay you, doing pay raises and that type of stuff, they have the union hires representatives that then go to the company and say, all right, cost of living has gone up this % this year, so we'd like this big of a raise and so on. Yes? So you get like this, all the workers are grouped together in this union. Now, if the workers aren't getting what they'd like, as far as benefits or pay, often they will go on strike. So they'll tell the company, well, there's 500 of us that are working in this plant making this kind of car. We're gonna stop working until you agree to some of our demands, or we have, like better health care, or kind of whatever. So I'm not trying to argue whether these are good or bad and historical, blah, blah, blah. Okay, but the point is, if you have a place, like if I decide I'm going to have a teachers union here at Westside Christian, and me and Mr. Camper, we're in the teachers union, and you need to raise our pay or we're going to quit, what's Mrs. Crosu going to say? See ya. It's like, be gone. But if all the teachers are in a union and we say, hey, look, our health care isn't good enough, we're all going to quit, she has to pay more attention, yes?
Yeah.
See?
Because if all the teachers quit on the same day, suddenly it's like, you have like 300, 400 kids, if you count preschool, that's like, what do we do with these kids? So here's the point. Unions are only strong when they get like everybody in it. So I want you to kind of have this mental picture in your head that union in math is kind of like that. Union kind of like anybody that's a part of it all gets sucked into, all gets included in this union. Fair enough? So the word for union, and we're focused here, is going to be or. Put a capital or there for dramatic emphasis. So that's what we've been doing so far. If you think about it, as we've had absolute value, our solutions have been x is this or x is this. We've been doing unions so far. And union is going to be everything that's in one or both. So as we go through and graph these things and we're shading one direction or the other direction, anything that's shaded once is going to be included in the answer. It's not like what we were doing on the last page where it has to be in both for it to count. If it's in either one of them, so this one here, if this had been union instead, and it's all these numbers going to the right, all these numbers going to the left, what would the answer be if this had been union? Everything. Because every single number is going to be greater than or equal to 2 or less than 4. So the answer would be all real numbers, not that. If it had been union, if we'd had an or there instead of an and. So, okay. So let's go down and see what we get when we do this union stuff. So If we graph x is less than 4 or x is greater than or equal to 6, all right, x is less than 4. We'll take that one. I have my 4. Open circle or closed? Open. And I shade to the left because x is smaller. Smaller numbers are there on the left.
Are we drawing an arrow?
I would, yep. Sorry, John. Then x is greater than or equal to 6. So we have our 6. We do a closed circle because it's or equal to, and we shade to the right. So if it was intersection, the answer would be nothing because nothing is in there twice. But since it's union, it keeps both of those. Both of those are going to be the answer.
Except for 5.
Well,
4.1.
every number between 5.9 repeating going down to 4 would not be part of the solution, but every other number in the world would be. Okay, so this next one, solve and graph. We do the same sort of thing as before. We solve first of all. So plus 5 gives me 3x is less than or equal to 12. Then I'm going to go through and divide by 3. So I get a x is less than or equal to 4. I'm going to go and graph my next one first, or I'm sorry, solve my next one first to see what that looks like. So this next equation, inequality, first I add 6 to both sides. I get 4x is greater than 28. Still tracking with me? Then it's because it's 4 times x, we divide by 4. X is greater than 7. All right, so now we can graph this thing here. I have a 4. Open or closed? Closed. And we shade to the left. And then we have a 7. And on the 7 we do open and shade to the right. So our answer then would be these two things, those two inequalities, those two shaded regions. So the answer is everything that's on there.
So you just shade, you don't write anything?
Sometimes you'll have those overlap, and it's possible to get an answer that would be all real numbers. Fair enough?
Yeah.
Okay, these last two, it was a real pain to try to get them to be drawn right, so I figured we'd just quick draw it in class. So this first one I want to draw in, so if you could copy this down on your number line. So we have a 2 with an open circle, and we're going to shade that to the right until we hit a closed circle, filled in circle at 9. And so let's do this one first. So once you get that drawn, think back to these last two sections we've done in the notes. Does this look more like intersection at the beginning or union at the end? Intersection. So most likely it's going to be one of the things where you have this x in the middle and you have the less than symbol on either side of the x. Fair enough? So, but now one of those has to be less than or equal to. Which one? Left or right?
Right.
Right. Because we have a filled in circle here. That has to be the less than or equal to. Because we have an open circle here, that's going to be just the less than. Okay. Now from there we just put in our endpoints. So on this lower end we have the number 2. And on the upper end over here we have the number 9. So 2 is less than x, which is less than or equal to 9. Yeah, so this part's not bad. It's not as intimidating as maybe it would seem. Very last one, and then we are done. I have a 6 with an open circle shaded left. So 6, open circle shaded left. Then I have a 10 with an open circle shaded to the right. So I'll give you a second to draw it. And union or intersection? Union. So that's where we're going to have two different inequalities. And then in the middle we have the word or. And on the left we could say x is anyone?
Less than 6.
Perfect. X is less than 6. Like the less than, because it's not filled in, it can't be or equal to. X is less than 6. Or x is greater than 10. Once you have those, we are done. Any questions on stuff we did? All right.